Video will be understanding the testing on Johnson counter. So it's a type of synchronous ring counter in which the complemented output of the flip-flop is connected with the input of the first flip-flop. Johnson counter can be made with the D flip-flop or JK flip-flop in cascade setup. The mode of Johnson counter is high to transfer the data parallelly, and the mode is made low to shift the data by one register each. Circuit diagram with respect to ring counter. So for Johnson counter, the only difference is you'll be adding a NOT gate as discussed above from pin number 10 to pin number 1. So let's see the two truth tables here to understand. So now the desired out QA, QB, QC are the outputs. These are the desired outputs, and these desired output has to be given as input with respect to port number 2, 3, 4 and 5. So one can observe that A, B, C, D towards the left are the inputs and QA, QB, QC, QD are the outputs. So the first row only should be given as input by making mode high. So set the input, make mode high, and then press the clock pulse. All the data will be transferred parallelly to your output port, that is for QA, QB, QCA and QD. And for the second row, you can observe that we have given mode should be low and we have to press the clock again. So once the clock has been pressed, QD comes through NOT gate to QA. So QD is 1 for the first row, QA is 0, NOT gate of 1, and then the data is being shifted by every register. Similarly, for example, for part in B, another example. So QD is 0, so NOT gate of that is 1, which appears in second row under QA. So according to this, we have to verify the truth table in the conduction part. So this is the design part with respect to the truth table. So let's see circuit connection. Let's see the circuit connection for Johnson counter. So these are for 16-pin IC. So your inputs A, B, C, D and mode M, your output QA, QB, QC, QD and the clock pulse as shown. So this is your IC 7495. For the 14-pin IC, you can see the bottom two are being neglected. So 8 and 9 been short circuited, connected to clock. Pin number 6 is connected to mode, that is your input. D, C, B, A are connected respectively to pin number 5, 4, 3 and 2. Pin number 10 has to go to the output QD as well as through the NOT gate. So pin number 10 has been connected directly to 1 here. That was for Johnson counter. So we'll change that shortly. Pin number 10 goes to QC. Pin number 13 goes to QB. Pin number 13 goes to 12 goes to QB. 13 goes to QA. And then 7 is being grounded. 14 for VCC. And for Johnson counter as mentioned, we are taking help of a NOT gate. So 7404. So for that we are connecting pin number 7 to ground and pin number 14 to VCC. And so as you can see, pin number 10 is being connected now to 1 of your NOT gate, and pin number 2 is being given to pin number 1 for 7495. So in this way, one has to do the connections. Realize for Johnson counter, the only change as you have seen is pin number 10 is connected through a NOT gate. There is QD output is NOT gate, it is going through NOT gate to pin number 1. So let's verify the truth table. So let's switch on the trainer kit, and as per the table, we want to see the output as 1011. So let's give the input also same, it's 1011. Make the mode high, then set the clock pulse. So you can see we have some junk value. As I give the clock pulse, I will get the desired or the designed output, that is 1 0 1 1. And now the next, for the next clock pulse, I'll get this one as it's 1 1 is not get is 0. So the 0 would come here, and then every after the clock pulse it will shift for every register. So this 1 would come here, this 0 would come to QC, and this high would go to QD, whereas QD high would go as low to QA on a clock pulse. Why low? Because we have counted a NOT gate from QD to 1. So after clock pulse, sorry, here you can see the mistake is I have not set the mode to low. Pin number 6 has to be set low, and then give the clock pulse to shift by every one register. Yes, so you can see now we have 1101 as per the table, and after next clock pulse, this 1 becomes 0 and comes here, these two 1 would come here, and this 0 would go here. So as per the table, it is 111 and 0 after a clock pulse. So in this way one can verify design for different truth tables for a Johnson counter. Now let us realize for Johnson counter. Thank you for watching the video. Please do subscribe the channel to enhance your knowledge further.